Welcome everybody to the IET's Engineering and Technology Magazine webinar, Introduction to Industry 4, Megatrends Impacting Our World in the Future, which we're hosting in collaboration with DesignSpark and Molex. I'm Alex McLeod from E&T Magazine. During this webinar, we'll discuss how trends such as globalization, digitalization and population growth are changing the world we live in and the related challenges and transformations for our factories. We'll provide you an overview of these insights, as well as the solutions that Molex can propose to support this digital transition. Our speakers today are Thierry Bieber, who is Business Development Manager for Industrial Solutions from Molex, and Greg Cameron, who is DesignSpark Community Manager from RS Components. Before we start, I'm going to briefly run us through some housekeeping. Within the speaker bio area, you'll see little blue arrows underneath the photos. If you click on these, you'll expand this area and can read the background of our speakers. You can increase the slides area in front of you by clicking on the Maximize button in the top right of the slides window. You can press F11 on your keyboard to maximize your screen, and press F11 again will bring everything back. You'll see a Q&A box on the right-hand side of your screen underneath the related resources. Please enter your questions as you think of them during the webinar by typing them into this box. Answers will not be displayed. Instead, towards the end of the webinar, about 45 minutes in, we'll answer some questions that have come in, so don't miss out on this opportunity and submit your questions early. We'll aim to reach all your questions, but any we don't get, we'll follow up afterwards. During the webinar, if the slides aren't moving in front of you, you may need to refresh your screen by pressing F5, and for slow connections, you might need to do this regularly. I'd like to highlight a few of the widget buttons along the bottom of your screen. You can open a widget simply by clicking on it, and then close it by minimizing, dragging, or resizing it to anywhere on your screen. If you're having technical issues, then please click on the yellow question mark widget in the middle, which directs you to our help pages. Here, please test your system, check minimum system requirements, and review the FAQs. If an issue persists, submit the problem to us in the Q&A box, and we'll help you immediately. You'll notice the related resources list on the right-hand side of your screen. At the top of this list, you'll see a link entitled "This webinar will go towards your CPD." You can go to this link, log in to the IET's Career Manager, which is under the heading "How is the IET supporting me in this process?" and register continual professional development time for attending the webinar. If you can't see the related resources list on the right, then please click the grey widget or put your request in the Q&A box, and we'll send you the website link you need. Within the related resources list, you'll see several links to various Molex and DesignSpark information pieces. Do click on as many of these as you want to. That's absolutely fine. The slides aren't available for download. However, everyone will receive an email within 48 hours with a link to the recorded webinar, so you and your colleagues can go back in, view the webinar again, and also submit questions to the speakers after this live session. Once we've finished, you can't immediately submit questions. You have to wait for the recording to be available, but you can do that fairly soon afterwards. Finally, in the widget panel, you'll see a black clipboard widget. Please click on this to give us your feedback in 3 easy tick boxes at any time during the webinar. Okay, so enough housekeeping. I'm going to hand over to Greg, and I'll move the slide over for you, Greg. Oh, you've just done that. That's great. So yeah, over to you, Greg.
Thank you, Alex. Hello, I'm Greg Cameron, the DesignSpark Community Manager. DesignSpark is the technical community for RS Components. Thank you for joining this webinar today. Today, we've teamed up with Molex to discuss the megatrend that is Industry 4.0, which has the potential to revolutionize the way industry and business conducts itself. In an ever-increasing connected world, there are many benefits to have by implementing a robust Industry 4.0 strategy. Today, we're lucky to have with us Thierry Bieber. With over 10 years' experience in industrial communications, Thierry is well placed to tell us the benefits of a robust implementation plan for Industry 4.0. And with that, I'd like to pass you over to Thierry.
Thank you, Greg, and hello, everybody. So my name is Thierry Bieber, as mentioned already several times, and I'm working as a business development manager for Molex in the automation world since many years. And I'm focusing now on the Industry 4.0 related technologies, understanding the requirement of the customer, the future requirement, how the market will move, and what are the technologies that will be relevant in the near future. And today I want to introduce you this Industry 4.0 concept, as well as the related trends that I see in the market, how I feel this will impact our automation industry, and as well give you some possible solution to start with this transformation process. So let's start with the question, why are we speaking about an Industry 4.0? There are some megatrends that are currently changing our world, our daily life, and that will impact the way we will need to produce in the future. First, the population is growing fast, and a lot of new consumers join the middle class, requiring a lot of new products. As well, the technology is changing faster than ever. We see that every day, and the IoT is now everywhere. It is interconnecting several aspects of our daily life, and is driving new expectations, as well as it opens new possibilities that can be applied in an industrial context. The globalization with internet is already happening since several years, and it reduces the distances. Now you can order parts from everywhere in the world with the expectation for delivery in the next couple of days at your home. This implies as well that the logistic is getting more complex, that the logistic needs to react in real time with dynamic solution, with high synchronization and traceability of the flows. And beside of this globalization trend, a parallel trend toward local and personalized experience is pushing. Customer wants to pay less or only for what they need. Customer requires always more individualization of the product, of the services, and the challenge will be to support this individualization with a mass production system at mass production cost. And so we speak here about mass customization requirements. And next to all these production trend increasing the demand, our planet is as well a limited world, and sustainability is mandatory. So we need to do that using less resources and generating less pollution. So what are the targets of this Industry 4.0? These mega trends put strong requirement on the industry, and new solution needs to be implemented to reach strong increases of the competitiveness of our industry. So when we speak about increasing the competitiveness, we may speak about increasing the efficiency of the existing production equipment. It means producing more, faster, with a better use of the energy and the resources available, and reducing the waste. Increasing the competitiveness as well by a shorter time to market. That is vital nowadays to stay ahead of the competition, to develop faster products that are getting more complex, and as well to be able to get them quicker in production. For that, we need to enhance strongly the flexibility of the existing production line, of the new production line, supporting so fast production change to reduce the time to market, to leverage the installed manufacturing capabilities, producing more part numbers in local plants across the globe, and supporting as well this mass customization. So what is Industry 4.0. So first, Industry 4.0 is originally a German term with industry instead of a Y at the end with IE. You see the two writings. So Industry 4.0 is a German initiative to focus the industry on the innovation that will address the new requirements of the future. 4.0 is meaning the fourth industrial revolution after the water and steam power mechanical manufacturing as the first revolution. As a second revolution, the electrically powered mass production. And the third one, in which we are today, is the electronic and automated manufacturing. So this fourth revolution is now based on cyber-physical systems. This is a very complex word to describe the digitalization of the manufacturing industry, which is based on one side on the digital twin, which is a digital copy of the real things. A thing may be a machine, maybe a drive, a robot, a device, a product, can be a screw as well. And so this digital twin will be mapped according to, and here I represented the RAMI data reference model on the right side of the screen of the slide, which seems to get some common international consensus for this standard. This data model should represent the different aspects of the thing, the product, the production equipment, and the interaction of this equipment during his whole life cycle. On the other side, the fourth revolution is based on the digital interaction between these digital twins, the interaction together, and as well in synchronization with the real automated manufacturing process. So, but let's look more in detail about our current automation situation and the possible path to make this transition, this digital transition happening. So here you have a representation of today's architecture, and the first question is this infrastructure prepared for this revolution? You see on the top the enterprise level, which is also called the IT with ERP softwares like SAP, which is currently separated from the plant floor, or OT, which stands for Operational Technologies. On the OT, you have the control level with MES systems, with visualization systems, talking to the PLCs, which is the brain of the line or the brain of the machine. And at the field level below, robots, drives, sensors, vision system are acting as the arms and the eyes of the PLC. So these systems are strongly organized in multiple layers with a communication top-down or master-slave. Topics like the safety, managing the security of the machines, are still made in parallel by additional devices here on the slide in red, or additional infrastructure clustering so the production architecture. And security is managed mainly at the entry door of the factory. It is not such a concern once inside the factory. So what are the trends that will impact our current automation infrastructure? And how can we prepare to this transition to the fourth industrial revolution? The first trend is related to the integrated safety management, or related to the safety management, which will get integrated in devices. Today, there is a consolidation of the network, which is happening. The networks in the machine. So the traditional parallel and often hardwired safety management in machines is getting integrated more and more together with the control infrastructure in the machine PLC in one single infrastructure, allowing so a more scalable control of the safety management. So the traditional protocols like Profinet, Ethernet IP, EtherCAT have all their safety profiles allowing this transition. Complex machines like CNC and robot controllers are integrating and expanding this safety management to improve their capabilities, for example, to interact with humans. And here, for the robot, we very often speak about collaborative robots, which interact hand in hand beside humans. As well, for AGV, our autonomous vehicle, they integrate as well safety to act autonomously outside of what we call the protected production cell. And with these autonomous capabilities, this opens opportunities to introduce new logistic solutions which are different from the current line-oriented production process. So for trend 2, distributed control. The automation devices installed on a machine are getting smarter, and with extended sensing or control capabilities like vision system or servo drives. They are as well extending their communication capabilities with the field bus protocol mentioned before, and with optional safety capabilities, as well as traditional digital and analog sensors are implementing communication solutions like IO-Link, which allows the communication to the last meter in the machine, that means down to the sensor level. So with this infrastructure, you can now access to larger amounts of data and to control information and exchange this information. We see that more dedicated manufacturer-specific functionality will be integrated into devices to consolidate and process this information, to simplify the use for the end user of these complex devices. We also see the emergence of some logic within these devices or within the architecture of the machine to create a first level of control, which is located directly on the machine, close to the productive area. The logic as well, the logic programming is transitioning from the classic programmable languages like we know today, ladder logic, for example, to new configurable logic units based on predefined function library, which incorporates already dedicated and proven functional modules. So the benefit here is a stronger modularization of the machine. And with this module can be pre-validated, would be as well autonomous from a functional standpoint. And this modularization is as well simplifying the global control management of the machine, increasing the flexibility and the scalability of the machine, as well as providing a faster time to market for the design of new variants of machines or production plants. Next trend that we see, trend 3, machine-to-machine communication. The smart devices and machine modules within a production line now have information, have capabilities and requirements. The target would now is now to allow them to share information and to interact together without the need of a line control PLC. So here we speak for machine-to-machine communication. A long-proven communication technology called OPC UA is getting nowadays a very strong focus to interface these complex devices or modules within a machine. So OPC UA is an agnostic communication technology. When I say here agnostic, it means independent from the classic PLC manufacturers and non-proprietary. And nowadays, the implementation of these communication standards in smart devices or complex equipment like PLCs, robots, controllers, drive motion systems is increasing. Beside of OPC UA, some additional protocols like MQTT, which are a very simple protocol to share value between devices, are as well emerging. But the main train stays on OPC UA. Machine profiles, technology profiles, or application profiles for OPC UA as well currently in definition, in order to simplify and to standardize the description of the data for the different machines and for the different functionalities, for the different technologies, communication technology, in order to allow an easy and direct interaction between these different elements together without too much programming, in order to transition from a data and very PLC-centric automation into a more capability and horizontal oriented automation organization. As for the trend 4, the sensor to cloud connection. We started with the smarter devices and IO-Link as communication technology down to the sensor level. This opens also new ways to interact with the machine, with online diagnostic, parameterization of the installed devices by or beside the classic control process driven by the PLC. So we just saw the trends for OPC UA as higher communication, higher level and agnostic communication technology, bridging the OT, means the production line, with the IT and the digital world. So both communication technologies together provides a path from the sensor to the cloud. So to create this path based on the huge amount of information that could be generated on the production line, new data management architecture appears at the edge of the production line, and with dedicated devices in machines or directly at the cloud level. We speak here about terms like edge gateways or edge computing. So their task is to collect data from the production line, to format this data, to filter, and to aggregate them. Their task is as well to run as well different algorithms like pattern recognition within this data, machine learning, artificial intelligence modules, and the edge devices will then interconnect this machine further to the cloud-based application or with other IT software like ERP systems. So the target of this edge solution is to provide early detection about the process quality, the production equipment health, or to provide reactive and actionable inputs for the people around the machine, like the operators or the maintenance people, in order to increase their understanding and reactivity in case of issue. The target is as well to bridge this IT and OT world without impacting the complexity of the current PLC control structure. As further, okay, sorry, I may have missed to swap some slide. I'm apologizing. Some further trend is trend number 5, the real-time IT/OT communication. With this new merger of the IT and the OT communication infrastructure based on Ethernet, this new interaction should not break the communication reliability and determinism that has been key to increase the production cycle times of machines over the last decade. So we see that new data transmission protocol like TSN, which stands for time-sensitive network, provides mechanisms that guarantees low latency and as well high availability transmission for dedicated applications. Today, TSN is finding some consensus in many industries, for example, in audio-video broadcasting, for in-vehicle communication, as well as in industrial automation. So TSN is seen now as a replacement of the current Ethernet transport layers, and brand new initiatives from large automation players are pushing TSN together with OPC UA as the long-term replacement for the traditional field buses, like Profinet, Ethernet IP, may be replaced by OPC UA. An announcement has been made on last SPS trade show 2 weeks ago, where 22 companies has agreed to push this solution as a long-term strategy, from which, and the companies involved in this initiative were the major PLC manufacturers like Siemens, Mitsubishi, Rockwell, as well Molex is part of the companies supporting this initiative. So the key benefit of this technology transition is the opportunity to remove barriers that exist currently between the IT and the OT networks, and that are often today on separated infrastructure and with separated technology. So it will allow to open the network in a fully transparent and flat infrastructure. Trend number 6, the cybersecurity challenge. So for the majority of the production system installed in our factories, cybersecurity was not taken in consideration, and updating regularly the installed devices is not part of the maintenance processes. Here, the credo, never touch a running system, is the main commandment. So increasing the communication capability and the openness of the industrial networks increases as well the risk of attacks on these applications. We see that the security strategies already in place in the IT world will move more and more into the OT world. New standards like the IEC62443 were released, and that describes or defines how the security should be managed in manufacturing installations, from the processes, the security processes, down to the security requirement of devices. Security by design concepts have to get common in the development of these automation equipment and in factories to secure against cyber attack. To secure against cyber attack the Ethernet ports and the integrity of the automation devices, and this is even more important for the devices managing the safety of the machines. Additional security systems like industrial firewalls will be installed as well to segment the network and to protect legacy machines that needs to be included in the company networks. So we see these different changes and trends. We see through these changes a true opportunity to interconnect the automation infrastructure and equipment together with distributed control, autonomous modules of machines, and with real-time, reliable, and secure transversal communication. So, to achieve the expectation of flexibility and time to market required by the Industry 4.0, we see that the current manufacturing process will progressively move to a more and more interconnected and flat infrastructure. The rigid PLCs, the PLC controllers of the production line that we have today will stronger evolve towards the modularization of the production function. The smarter devices like servo drives or multifunctional sensor vision system will collect more information in one single point, allow pre-computing of this information, and the machine themselves will integrate more and more logic, taking charge data collection related to their own state, production information, diagnostic, energy consumption, quality of the production, and so on. And as a final target in the coming years, this autonomous machine will interact in real time with the ERP system for real-time production planning. The production line can, for example, get then from ERP system the product setup ordered by the customer, and so react or adapt the production on the fly to its requirements. The ERP system will get instantly the status of the production machine, its performance, maintenance predictions, and maintenance predictions to order spare parts before failures. The robot safety management is evolving as well to allow stronger collaboration with humans, to increase the flexibility of the production line and simplify or speed up the production steps and the changeover time. With the use of the self-guided vehicles or AGVs, these devices are breaking the linear production line, as already said, are driving the production, are driving the product to the next available cell, which has the capabilities required by the production process for this product. So in fact, the production will now be driven by the product instead of be driven by the line PLC like it is today. The second transformation will be as well related to the business model and the way we do business today. Today, the communication stays mainly inside the production line. Factories tend to limit as much as possible their interaction with the external world. And remote access means access to the plant from an external place is just starting to emerge, mainly to help customers in case of maintenance, to support the interaction with their suppliers or internal experts. So with the smarter devices, the complexity and the expertise required is increasing, and this remote assistance demand will grow significantly. With the emergence of the sensor to cloud communication capabilities, the data available about the process and the devices themselves will drive new opportunities to collect this data, focusing on the management of the assets and the production unit. So these new asset management communication paths will allow new services which will drive the business model of the future. Like, for example, with the new data collected, data analytics can discover patterns in the data, drive the optimization of the production quality, the resource usage, and the equipment maintenance. So the traditional IT players are pushing hard to enter in this segment to offer to end user the platform for the storage and the management of this data. Tools are as well made available for the analysis of this data, generating the value out of this data. As well, with the remote access, equipment manufacturers like robots, drives, would require these data as input, as feedback from their end customer, from the life cycle of their devices, in order to improve online the design and the production of their devices. Machine Builder can propose to customers maintenance services, production, or availability guarantees, or can also rent the machine in a pay-per-use service model, offloading the end customer with the management of the production equipment. So strong changes to how we do the automation today. So Molex, out of its industrial automation business unit, is a leading supplier for communication and infrastructure solution for the manufacturing industry, with a strong focus for the infrastructure installed on machines, means with an IP67 protection grade. And so we took a closer look at how these transitions will impact the solutions that Molex is already supplying for this market. So the Industry 4.0 infrastructure is more going through a natural evolution of what we have today. Here we do not speak about a real revolution. The production line will still use robots, sensors, actuators, HMIs that requires infrastructure with power and communication distribution. Mainly here, cost and performances will be improved to support larger bandwidth and the communication capabilities of this transition. The real change and revolution of Industry 4.0 happens at the software and communication level. Here, as we already spoke about that in the previous slide, the communication path and the enhanced evolution flow, information flow will allow at digital level to take more decision, generate stronger competitiveness improvement on the production capabilities. So the infrastructure is a key element of this transformation and will incorporate more processing and communication capabilities than it has today. Here we see a strong change and evolution in the way that we are managing the automation infrastructure of today. So in the production area, the automation devices will move stronger from the cabinet into the machine. So the number of sensors and equipment installed will continue to increase, driving the demand for IP67 solutions and reliable connectivity in a harsh environment. So Molex, as one of the historical leader supplier in this domain, has a very complete portfolio that would satisfy the dedicated requirement of the various industries. We speak here about the traditional RON connectors like the M8, M12, 7/8-inch, or M23, or rectangular heavy-duty connectors for power and signal interconnection, mainly between the machine and the cabinets. So further initiatives are as well starting nowadays, especially in Germany, to standardize as well the connector at the interface of the machine in order to consolidate and modularize over one connection the different power, communication, and signal requirement of the machine, and to put all that in one single connector. Target is to push for another level of modularization of the machine. Have the plug-and-play module at the machine. The sensor and actuators installed in the field are getting smarter, as already explained, and Molex promotes the IO-Link technology to extend these data exchange capabilities with the sensor with online parameterization or diagnostic. So the Molex IP67 IO-Link module is a cost-effective solution as a single concentration point. The target here is to connect all kinds of sensors which are in a dedicated functional unit of the machine, to connect all sensors which are digital, analog, or with native IO-Link communication support, and to interface them with the traditional Ethernet-based network of the different PLC manufacturers, like Profinet or Ethernet IP. We see here in this module the central point of the infrastructure of tomorrow, and we are expanding the capability of this module for the coming year with additional IO-Link safety support in order to include to this digital, analog, or IO-Link communication support, as well the safety devices, having then all devices that would be all the equipment available in this machine connected to this module. As well, this module will be extended with OPC UA next year to make the connection to the cloud or to the edge solution, and would incorporate as well a standard or safe logic runtime to allow to implement a first level of intelligence, of control, and to support the modularization trend. The amount of data available in machines and that will be used in the future for predictive maintenance or data analytics is very large, and it's changing the requirements of communication on machine with a transition to Gigabit Ethernet in the field. So Molex has for these requirements a very large portfolio in ROM connector as well, with classic D-Code M12 solution, the Gigabit Xcode M12 connector, or diverse RG45 solution, or with or without PoE support. For more compact smart devices that requires power in Ethernet interfaces in one single connector, the Molex THC here in the middle of the picture supports shielded Ethernet plus 4 power conductors in one single M12 housing. We see here in this connector, in this communication technologies and connectors, that some changes will as well occur in the future. Ongoing discussion in standardization groups are pushing for next generation solutions. Today, a two-wire Ethernet communication mixing Ethernet and power is in discussion in order to simplify the infrastructure and reduce the cost of the infrastructure in machines. As well, the wireless 5G communication will have its first implementation very soon, and is providing today strong promises regarding the performances and the bandwidth. These both technologies may have as well here significant impacts on the infrastructure as we know them today. With the complexity of these diverse requirements that machine builder has to comply to, Molex is supporting its customers with the definition and the layout of the infrastructure in the machine based on our standard products, or as well with the definition of customized solution. So the target is for our customers to reduce the number of components in this infrastructure, to increase the flexibility of the assembly, and to have a plug-and-play system that will minimize the installation time, especially by the end customer. Once the machine installed, Molex proposes industrial secured routers to access remotely to this machine from everywhere in the world. Router is installed on the machine and will open a secure and encrypted communication with the central management cloud. And to guarantee more security or acceptance of the end customer, a switch can disable by default the remote communication and apply it only when decided or required. So the central cloud platform is managing the access right for internal or external suppliers or customers, and allows a seamless access to the dedicated and authorized machine. So end customers can so control the machine in their different plants across the world, but also allow their customers, machine builders, for example, to have a visibility on a dedicated part of the network or the machine, so that they can provide services for this machine. So the cloud managing this interaction is either public for hosting easiness, or can be private for stronger control of the data and the security by the user. So this platform is as well an ideal solution for device manufacturers like robots, drives, or pump manufacturers to manage their installed base, to provide to end customers additional services like the remote assistance, preventive or predictive maintenance, scheduled spare parts deliveries, and so on and so on. So the solution can as well be completed with industrial firewalls that allows a secured segmentation of the production network to limit the contamination of cyber attacks, or for the integration of existing legacy machines to avoid them to be too much impacted by the existing networks or cyber attacks that can happen. Based on this long expertise of industrial application and as a result of the trend that we see in the market, Molex IAS40, IAS stands for Industrial Automation Solution. Molex IAS4.0 is our new vision for the future of automation. Molex IAS4.0 is an automation platform that integrates these 4 pillars that you see on the screen with industrial communication and safety capabilities to support standard and safe distributed control logic, as well as I/O drivers, access, machine-to-machine, cloud communication, and edge capabilities to support the interaction to the higher level. So the target for Molex with this platform is to address in a flexible way the requirement of the Industry 4.0 and to enable our customers to transition to this new era. So the platform will be available as a technology module for our customers, device manufacturers, for them to easily integrate and benefit of our communication and automation capabilities in their devices. The platform will as well be available in a series of products like the I/O modules that we have seen earlier in this presentation, or Edge Gateway that we talked about sooner, to support machine and line builders to transition from a pyramidal infrastructure to a more flat, modular, and horizontal automation structure. So this solution as a smart I/O module, showing this Industry 4.0 concept and trends in action, was demonstrated last month at the SPS fair on the machine that you see here on the right side of the slide. So the I/O devices were managing specific machine functional modules. The one from the left that you see on the left was managing robots for the loading the balls on the conveyors. Here the red balls on the conveyors. So one module interacting with the robot, interacting with the sensor, having the logic of this unit. The second one was the unloading part of the right robot, as well interacting with all equipment around this functionality. The third one with the management of the security and the safety of the machine, and the fourth one, the interaction with the cloud. We had on the cloud an order management system to collect the orders from the customers, and dashboards were as well showing the process execution and the metrics of the machine. So I was already very long with my presentation. I hope it was not too much information, and it's only some of the trends that we see, and there are many other trends that are relevant for this Industry 4.0. I want you to give the opportunity to ask questions, to share with your inputs and opportunities about this transition to Industry 4.0. Do not hesitate as well to contact me after the presentation, or to visit us on the next Hanover Fair in April 2019, where you can see our vision for the Industry 4.0. So I hand over now to Craig, that will be sending me your questions, your open question. I will try to provide some answers to them. Thank you.
Okay, thank you, Thierry. Very comprehensive presentation around Industry 4.0. We do have some questions coming in from you, from people who have been listening in. Is there any particular industries which are leading the way for Industry 4.0? Is there any particular sectors?
So today, I would say that the leading industry which is driving this transition, I would say the same as usual, is strongly driven by the automotive industry. Because there you have the biggest, I would say, or the strongest automated production right now, where they always try new ways to increase the flexibility, to where they have a strong degree of production variants or model variants, and they are as well strong input drivers for this requirement of this Industry 4.0. So today, doubtless the automotive industry is one of the drivers. We see as well that some of the machine builders, large machine builders, are really pushing the innovation, are pushing differentiation capabilities for their machine against competition, and they are as well strong drivers for the implementation of new solutions. And it's very interesting to interact with them to get this understanding of what can bring value to their end customer.
Okay, great. We do have another question just around the industry types. Industry 4.0, is it really only viable for large production facilities, or can small to medium businesses benefit from introducing an Industry 4.0 strategy, maybe around critical components, etc.?
So we speak about an Industry 4.0 where everything is digital, everything is interconnecting. So in the reality, there is not one single Industry 4.0, because I would say digitalization is a process. It's a process to really interface, interconnect a real world with a digital environment. And this process and transition takes time. Mainly the highly automated, the biggest production have today the biggest benefit of it. And they can afford the biggest investment, or the huge investment which is today required related to that, in terms of new devices, in terms of a lot of manpower to achieve this interconnection. But with the time going forward, these different standardization activities, these interfaces between the different devices will get unified. The effort related to the integration of an interconnection of the devices is getting lower. Will be more and more seamless, and will make this transition affordable for a lot more companies, as well to smaller companies. So with the evolution of the solutions, the Industry 4.0 is getting easier, and as well, there is no, in my opinion, there is no obligation to have everything digitalized, but create a digitalization project where it brings the biggest return on investment, where it generates the more value, either for your production, for the production quality, or for your end customer in the way that you provide digital services for your end customers. So that's my feedback.
Okay. That leads me nicely into, it's kind of like a two-part question, this one. How and why would you implement an Industry 4.0, and are there any common barriers that you need to overcome to do so?
It's a very wide question, which is I think, very specific from companies to companies, and I think as I mentioned before, the very first step would be really to look at where are your biggest expectations when you speak about an Industry 4.0? Is it an expectation in quality? Is it an expectation in providing services to your end customers? And based on that, for sure, if you have processes which are very manual, not very automated, the challenge to go there is even bigger, because the digitalization is very much linked with the automation of a system. So automation is a first level of integrating or going into an Industry 4.0 system, and then really the question is about the service or the benefit that you would like, because every different type of service or of added value is made via a different way. I can maybe, if somebody has a very precise question or precise request, we can look at I would say more specific questions. But as I said, automation is one pre-requirement. The targets, defining the target, and as well the bridge between the IT and the OT was often a topic during my presentation. So do not hesitate to put people from the automation world on one side with people from the IT world to see how they can, in the best way, make this bridge between your IT policies and your automation policies into your company, and how to build up this interaction between the systems.
Okay, great. We've got a couple of questions coming through which are really more specific around particular industries. We'll try and go through those and let you answer those. So within the water and wastewater industry, is there a solution which Industry 4.0 can do, or can it actually improve the running of those industries?
Sorry, the question was, is there an Industry 4.0 solution for the water and wastewater industry?
Yeah, does it work for that type of industry? Will they benefit from having an Industry 4.0 implementation strategy?
Okay, I'm now not very specialist in the water and wastewater industry, but for me, any industry would benefit from this process, because we really hear about this industry. It's more, I would say, a process-oriented industry rather than I would say a manufacturing industry. And here, the data collection, to have more data from this process, to have more data about the production equipment, as well as the water, the quality of the water, and all these interactions with the water is key, in my opinion, to recognize which are the parameters which can impact in a good or in a bad way to the process or to the target which is aimed. And by understanding this interaction, you can really fine-tune your process to limit the energy, to limit the resources consumed for this treatment, water treatment, and really to as well have a better traceability and a guarantee of the solution, of the result. So I would see here one of the first interaction, the second interaction, the maintenance of the equipment, predictive maintenance, understanding what will happen if a pump will fail before it happens, helps as well to really guarantee an availability of the production system. To guarantee better availability of this production system. So that would be some of the, I would say, benefit of this solution for this industry.
Okay, thanks very much for that. We'll take one more question. There are others, but as we mentioned earlier, we will get those answered and put back out very soon. I'd just like to take one more, Thierry. It's talking about, for offshore facilities, remote access, connectivity type of applications. How do you see Industry 4.0 being used within that kind of environment?
Industry 4.0 in offshore applications. This is what you...
Yeah, so where we're talking about remote access, connectivity through satellite, or is there something else that we envisage?
I would say for offshore industries and platforms, I think here, personally, and sorry for this answer, I'm a bit too far of this industry. I'm more focusing on, I would say, the manufacturing industry. So here there are several requirements about redundancy, about reliability. Everything is duplicated. So I don't know if here the remote access is well spread in this industry. I see that one of the difficulty in offshore industries is really the accessibility of the platform. So here, and if you mentioned before remote access connectivity, I see this opportunity as really a way to give a transparency to the equipment installed in this environment. But this transparency should be really made with this complying to security policies because of the criticity of this process. But having a supplier logging in the system, being able to access to the PLCs or to the robots or to the drive, to the pump, providing here services, maintenance, providing an understanding by connecting remotely to this device helps really to quickly solve some of the platforms, solve some of the problems that you may have on platforms without traveling there. Which, based on some of my experience, when we had to send some people there, it's directly a week. It's a week of travel to get there and to get back for the maintenance of a product. So remote access can be a really benefit. Now about the next and further application of Industry 4.0 on this environment, I'm not specialized enough to see and to predict what is happening there. Today, this topic is as well in investigation in the organization. I think the NAMUR, which is an organization which is in charge of the process automation solutions, is currently defining an architecture mainly for data collection, for data analytics, which is acting as a data diode, means only able to get information from the process into the cloud and not interact in the reverse way. I think that is a compromise that would allow to open the access to the network without having the criticity of hackers entering the system, changing the way the production facility behaves. So there are some other activities that are currently ongoing in the NAMUR organization, which is the organization for the process industry.
Okay. Thanks very much for that answer, Thierry. Before we finish, there is just one quick question I'd like you to answer, if you could. We have a user who's saying they want to start implementing an Industry 4.0 strategy. They want to get data of critical devices within their production facility. Would edge computing be like a good starting point just to monitor maybe single motors which are critical for production lines, etc.?
Yeah, this edge solution are something which is beside, I would say, the traditional control solution, which is really dedicated in the defining and with a PLC determining the behavior of the motor. If these data reach monitor a drive to monitor any kind of device in this platform, these are new processes, and the edge solution or the edge gateways, edge computers are in charge to interface with this device, connect to this kind of, I would say, new difference diagnostic information or state of the drives, or you can as well equip this machine, the existing machine, with new sensors like vibration sensors, temperature sensors, why not noise sensors, and a new kind of devices like these edge devices can either process this data, or if the amount of data is bigger, and this edge gateway will collect this data, send them to a cloud, into a database, and you can then process afterwards this data with dedicated softwares, big data mining softwares to recognize some patterns, to recognize different interaction between different parameters, detect some relevant patterns for this health of a pump or of a drive, and so afterwards really monitor this dedicated items or information or data, really monitor for this specific pattern in order to recognize and detect earlier a defect. So that would be really the process, and the target is not just installing a single device and an edge device and it will run. It's really a process to implement this strategy. But edge devices is really the type of devices which is dedicated for this new interaction with the production plants.
That's great. Okay, thanks, Thierry. And thank you very much to Greg. And of course, thank you to everyone who's joined us and indeed who are watching us on demand over the next few months. So as both have said, if you have any unanswered questions, they'll be followed up after today. And I'm sorry we didn't get a chance to reach them on this webinar. If you think of other questions, if you're watching this on demand, you can still use the Q&A box that you can see on the right-hand side. So feel free to put your question in. We'll hopefully get to them. As we do, we'll be checking back on this webinar over the coming weeks. So you'll get an email within 48 hours with a link to the recorded webinar so that you and colleagues can go back in and view, and you can also skip to the bit you want to watch again, and you can submit further questions. The webinar platform will be unavailable while we prepare the recording over the next half an hour or so, so do follow the links from the email that you'll get in the next 48 hours. All that's left for me to say is thank you very much for watching. We hope that you've enjoyed the webinar, that it's been useful, and we wish you a very, very happy holiday. Thanks from everybody. Bye-bye.